Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to use basic opencv color tracking method, and then we are going to detect traffic signal light which is red and green color with the help of basic opencv color tracking method. And then we are going to use latest object detection method which is YOLO-v10, and we are going to detect vehicles which basically violate the red traffic light signal. So this is what our goal. First we are going to detect a traffic light, and then with the help of YOLO-v10 we are going to detect the vehicle which violate the red light signal. Simple. So this is what our today's project. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, for today's project, first we are going to install our basic packages. So just open Tony Python ID, and as we always do, just open tools, manage packages, search for opencv-python. opencv-python, just hit enter button, first package, click on install button. That's it, it will install opencv-python. Then we need ultralytics package, ultralytics, hit enter button. Then we have our first package, ultralytics. I think there is some typo mistake. ultralytics. Okay, now we have our result. Ultralytics first package, simply click on install button, done. It will install ultralytics. Then we need cv zone package, first package, click on install button, done. It will install cv zone. So this is how. Simply open tools, search for opencv-python, ultralytics and cv zone. It will install all our basic packages. Done. So we have done with package installation. So for today's project I have created a new repository. I will mention the link. Simply copy paste the link inside the web browser. Red traffic light violation. Just click on code and click on download zip. It will download our zip format repository. As you can see, we successfully download our repository. Open file manager, go to the downloads, and this is what our repository. Right click, WinRAR, and extract as a folder. Then we have our folder, red traffic light violation, again same folder. So let's just first watch our video file, tr.mp4. This is what our video file, and here it is. As you can see, right now there is a green color signal, so traffic is moving over here on the road. And as I mentioned, we are not going to detect this side traffic because we don't know about this side signal situation. We are seeing here only this side situation of the signal movement, we can say. So we are only going to detect this side vehicle. Simple. So right now there is a green color signal, so of course the vehicle is moving. So now as you can see, the red color signal, and this car, if there as you can see, basically the signal is red but this car is not stopped, so it means this car basically violate the red traffic signal rule. So as I mentioned, our goal is to first detect the traffic light. So for that we are going to use here basic opencv color tracking method with the help of contours also. So we are going to use a color tracking method. Then we have our latest object detection model which is YOLO-v10, which detect the car. And then here what we are going to do, this is the area. As you can see, this is the area which is basically our region of interest area. So our condition is what? If the signal is red, and if the car inside this area, then we can say the car is basically violate our traffic signal, because when the green signal is there, car is continuously moving. Okay, so car is moving, so there will be no stop inside this area. Any vehicle, if the traffic signal color is basically green. But if the traffic signal color is the red. So this is what our stop line, as you can see, this is what our stop line. So if the vehicle cross this stop line and if it is inside our area, then we can say the car is basically, or any vehicle is basically violate our red traffic signal moment, or we can say the condition. Simple. So this is what our video file. That's it. So let's just start. First, as I mentioned, first we need to detect the traffic signal lights. So for that, as I mentioned, we are going to use a basics opencv color tracking method. So I have mentioned the code here. So test.py, this is the test code. So here it is, as you can see friends, import cv2, import numpy as mp. This is what our video file, tr.mp4, and then here we need, of course, for green color we need lower range and we need upper range, and then for red color we need red color lower range and we need red color upper range. That's it, simple. So how do we get the color range, the lower range and upper range? Simple. For that I have created here a tracker. So let me open. Inside repository we have track.py. We have here track.py. As you can see, just open the track.py, and here you need to mention your video file, or of course if you want to detect the color with the help of your USB web camera, so here you need to mention the camera index number. But right now we are not going to use here any USB web camera. We have our video file. So from video file we are going to detect the color, the traffic signal color. So simply mention the video file as a source, and then we have here basically track bars. So let's just open the, let's just run the track.py. So if I play the track.py, so this is what our mask. Inside this mask, what we want to detect, means what is our goal, what color we want to detect, you will get the mask inside this mask window, and this is what our main window. This is what our main window, and this is the track bar. As you can see, the lower H value, lower S value, lower V value, upper H value, upper S value, and upper V value. So this track bar we want to adjust with our requirement. So let's just say here right now the color is green inside the signal, traffic signal. So I just want to highlight, or we can say I just want to mask only the green color. There is nothing, there is no need to detect anything, or there is no need to highlight, or we can say mask anything. I just want to highlight my green color. So for that, simple, here we need to skip the frame one by one. So for that, simply, as you can see right now the frame is freeze. This is what my first frame. So if I want to skip the frame, so simply we need to press here space button from keyboard. Just press space button from your keyboard, and then the frame will skip. As you can see here, this car is basically moving. You need to press only space button. The frame is basically skipping one by one slowly. So now what we are going to do, as I mentioned, we need to adjust this taskbar. So basically track bar. So our goal is to detect the green color. So let's just say here I have already mentioned the color lower range. So here for green color I have mentioned, for this particular scenario the lower range for green color 58, 97 and 222. So let's just set our track bars. If I go here, and this is what our mask window. So 58 is basically lower value. So we set the lower value 58. Now you need to simply press the space button, and as you can see there is black color, or we can say there is a mask on other objects, So we have done with the lower value, which is the 58 for best value for detecting the green color. For this scenario, let's just say if you have another scenario and there is a signal detection, the color, it is completely depending on the clarity, it is completely depending on the lightning condition. What is basically your lower value, lower S value and lower V value for detecting the green color. You cannot say that this is the perfect value for a green color. Simple, there is something difference in between these values as per your requirement. Simple. So for this particular condition, for this video file, the 58 value is perfect for lower H value for detecting the green color. Then we have lower S value, which is 97. So 97, let me open other windows. So lower S value is 97. So let's just set 97. So now if I press space button, as you can see, all objects are now black. Means we just did here. This is the result window. Here it is. As you can see, we cannot see anything. Only seeing here the green color from our traffic light. Only green color. Now the lower V value is 222. So if I go here and if I adjust the track bar for 222, it just go as a 222. So now if I open all windows result and if I press here a space button, as you can see, now all objects are masked by a black color, and we have only here a green color, and this green color, as you can see, there is a white mask on our selected green color. Here it is. As you can see, there is only white mask available for green color because we set the lower H value 58, lower S value 97 and lower V value 222. Then you will get, for this particular scenario, then you will get your choose color mask. You need here a white mask inside the mask window. Then you can say that this is what my goal, this is what I want to achieve. I want to achieve for my particular color range. So for green color range, this is the mask. So for this is the range. So here, as you can see, I have mentioned this range with the help of our track bars. Now simply 58, 97, 222, and the upper range is, there is no need to change for upper range for green color. So here it is 179, 255 and 255. So same way for red color, So again we are going to simply stop our code, the track code, and again we are going to start our code for detecting the red color. Sorry, I have started the test.py. Let me start track.py. As you can see, this is what our result window, this is what our mask window. So for red color, I have mentioned here range 043 184, 043 184. So let's just go 043 43 and 184, 184. So 184, and the upper range 56 132 255, 255 basically. So upper range, here it is 56, upper range 56. So 56 and 132, upper S value 132, and the upper range V value is same 255. So now if I open our all windows, result window and the mask window, so we need to skip here a frame because right now there is a green color. So as you can see, this is the value for red color. So right now there is a green color, so there is no detection, there is no white mask inside the mask window, as you can see, because this is the value for red color, not for green color. So of course there is no detection. So friends, as you can see, for this value now in our traffic signal we have red color, and inside mask there is a white mask for red color. Here it is, as you can see, white mask. So means this is the perfect value for detecting the red color from traffic signal. That's it. So this is how you will get the color range. You need to simply adjust the value and just press the space button and skip the frame one by one and adjust the mask value. When you will get a perfect white mask for your color range, set the value inside the test.py, as you can see, I have set the value lower range, upper range for green color, lower range, upper range for red color. Done. This is how you can use track.py for getting the particular color range. So we have done with color range. Now simply we are going to, as I mentioned, we are going to use here simple color tracking method. So HSV value is basically cv2.cvt color frame, and then we are going to use here cv2.color bgr to HSV function. Then here we need to pass our frame, then create a mask for both color images, or we can say not images, basically the range. So create a mask for both color ranges. Mask is equal to cv2.inRange, the HSV variable, and we need to pass our lower range and upper range for green color, and mask 1 is basically for the red color. So cv2.inRange HSV and lower range 1 and upper range 1. Then combine the two masks because we want to detect the both color at the same time. So combine the two masks. So combine mask is just a variable, and cv2.bitwise, this is the method, cv2.bitwise or mask, this mask and mask 1. It will combine our both masks in one frame. Then now we are going to use threshold method, threshold the combined mask with the help of cv2.threshold method. So this first we are going to set empty, then final mask and cv2.threshold combined mask, and 254 and 255. Then cv2.thresh binary, this is a simple method. And then here we are going to say that detected label is none, because we want to set here a label if we detect a green color. So we need green as a label. This is the text label. So green as a label for if we detect the green color range, we want to print here a green. And if we detect a red color, so we want to print here a red as a label, because this label we are going to call inside our YOLO-v10 object detection code where we want to detect the car. So in that code we need the color detection, means we need a label of color. Then we can create our condition. If the red color, means if we detect a red label, then we are going to mention that if the car pass our region of interest area, then there will be basically we are going to mention on the object detection rectangle method, we are going to create a red color rectangle, means the car basically violate our red traffic signal. Simple. So for that we want here a detected label in text format. So as I say, when we detect a red color from our traffic signal, so it will create a red label, red color, and it will, if we detect a green color, so it will pass that we detect a green color. So it will basically create a text, a green. Simple. So for that, when there is nothing to detect, so in that time we simply said here that detected label if it is none. Simple. So we are continuing our code. If there is no detected label, so detected label none, then we are going to simply find the contours using our mask, final mask. So this is basic method. Contours, cv2.find contours, final mask, rater external, and then cv2.chain approx none. That's it. This is the basic method. And then for C in this contours, we want to mention the cv2.contour area, the C, if it is greater than 50, then we are going to create the bounding rectangle coordinates. So x, y, w, h is equal to cv2.bounding rect, and inside that we want to pass the C. Simple. Then we will get the rectangle method. Then for our drawing purpose, we need here a center point of each color. So cx and cy. X plus w divided by 2, we will get the cx, and cy basically y plus h divided by 2, we will get our cy. This is how we can draw the circle on each traffic signal light. That there is the center point. Simple. So as I mentioned, totally basic method for detecting the color. So now after that, as I mentioned, we want to determine the color of the contour. So here it is. As you can see, I have created the label green when we detect the green color, and when we detect the red color, we create here label as a red. So for that, we are going to simply use cv2.count non-zero, and then inside that we want to pass a mask for green color, this mask. So I have passed the mask variable, and then we are going to use here y colon y plus h, y colon this y colon, because this is what our rectangle for detected color. If we detect a red color, then we have the rectangle on red color. If we detect green color, so we have of course the rectangle on the green color. So we know that if there is a rectangle, it means we are detecting a particular color. So for that we are going to use here these 4 coordinates. So if the mask, so this mask variable we assign for green color, here it is, as you can see. So if there is a mask, so y colon y plus h, s colon x plus w. So this is how we are going to crop the rectangle, and then if it is greater than 0, then we are going to say that the color range is basically green, and then color is equal to 0, 25504. As you can see, the green color rectangle, this is the green color range, and the text color also we are going to mention green because we are detecting the green color, and the label we are going to create manually as a green. So same method for detecting the red color. As you can see here, I have mentioned the red color for color and text color as a red, and label is red. Now then continue, then we are going to continue. If we detect our label, means if there is a red or if there is a green, then what we want to do, detected label is equal to label, then we are going to draw the rectangle, and then we are going to draw our circle, and then we are going to put the text as a red or a green, whatever we have the color on particular traffic light. Simple. And then for testing purpose, here we call our code. While through method we are going to call our video file, and then here proceed frame, this is what our function, here it is, as you can see, process frame, and where it is, here process frame and detected label. This is two basically objects, we can say this is 2 objects we get from our function. This is 2 variable we will get, or we can say the result we will get from our function. So process frame is our function, and inside that we are going to simply pass our frame, and then we will get the process frame and detected label. This is the result. So if I start the code, so here it is, as you can see, we detecting right now there is a green signal on our traffic signal. So there is a green color rectangle, and the label is GREEN in text, green. So if I skip him, or let's just start a while loop, as you can see right now there is a green color signal and there is a red. So if you clearly see, when we detect, let me start again the code. If we detect the red color, there is a red color rectangle and there is a red color text, as you can see. That's it. So this is the basic code for tracking the color code and creating the label for detected color for traffic signal. So I have mentioned the full code inside test.py. I have created same code with test1.py. So this is the test1.py which we are going to call inside our main code. So test1.py is my final code where we have our function, and we are going to call the function inside our main code. So test1.py is my function where we have our color tracking and color detection and creating the label. Simple. So now simply we are going to open our pmain1.py where we have our yolov10 s.pt, our object detection model, and then we are going to of course detect here a car. So here it is, as you can see, here I have mentioned if car, if we detect a car and if detected label is red. So here it is, as you can see, from test1. So test1 is what? Test1 is basically our file where we have our function for detecting the color, for creating the label. So simply if I want to call the code from another Python file, so I just want to mention that file name without the .py. So the file name is test1. So simply I have call here from test1, means call the code from test1, and what I want to call here, I want to call my function. The function name is process frame. process frame, as simple as. So from test1 I will call my process frame function inside pmain1.py. That's it. And then as I mentioned, I just want to detect my region of interest area. So let me start here a code. So I have mentioned here 0 already. So first it will download our YOLO10 s.pt object detection model. As you can see, it's now downloading. And here it is, as you can see friends. So this is the signal detection code which I have already explained. So we have now green color. So green color text, green color rectangle. So as I mentioned, now what I want here, I just want to detect here only the car which violate red color signal. I don't want to detect the car when there is a green color signal. This is what my condition. So here I have create a region of interest area. As I say, so this is basically stop line. We can say this is the stop line. So if there is a red color and if the car or any vehicle cross this line and if it is inside the selected region of interest area, then we can say the car is basically crossing the stop line when there is a red color. Simple. So this is what my region of interest area. So how do we draw the region of interest area? Simple. We want to draw here a polyline. Here it is. As you can see, I have mentioned the polyline function. So how to get the points for drawing the polylines? For that I have here mouse event function. cv2 dot mouse event move function. Let me show you here. So here it is. As you can see, cv2 dot event mouse move function. So when I move my mouse cursor on the frame, we will get xy coordinates, as simple as. So if I want to start the polyline first point, let's just say from here. So here I have 323312. 323312. So this is what my point area. As you can see, this is the area variable, and inside that I have mentioned all the points. This is what my first point, this point, this is what my second point. So inside shell 284374, so I have mentioned the point over here. If I go over here, I will get the third point 857392. Simple. And this is what my last point. If I go here, I will get inside shell 865320. Here it is, as you can see. So this is how I have mentioned the area. Inside the code, I have already mentioned the area, so you can simply study the code. So I have already mentioned the area, and we are going to use this area for drawing our polyline. So here it is, as you can see, cv2.polyline method frame np.array. This is how we want to mention our area, then true, and the color for drawing the polyline. So I have mentioned here a green color polyline, so 02550, and the 2 is basically thickness of the polyline. Done. Now how do we know that the car is basically stopped inside our area, selected area? For that we have our cv2.pointPolygon_test function. So cv2.pointPolygon_test function which need the area. So I have mentioned the area. Here it is. This is what our area. So this is the area which we mentioned from here. This is the code. You need to simply copy this code as it is. Just copy from np.array to npin.32. Copy as it is. Just start from here and in at the here and just copy it and just paste as it is. As you can see, inside the bracket you need to simply paste as it is. And then here friends, what we are going to detect? We are going to simply detect cx and cy, because the rectangle center point, if it is inside our selected area, then only we are going to say that our car is basically inside our area. So for that we want to mention here cx and cy and the false. This is the method. Simple. So result is basically 1 or minus 1. 1 or minus 1. So if the result, if greater than or is equal to 0, means if it is 1, because if it is greater than or is equal to 0 means if it is 1. So if it is 1, so if result is greater than or is equal to 0, then we say that my car is basically inside our area. And here, so if we detect the car from our class, so we have our C is basically our class. So here I have mentioned if the car in C, and detected label, because we call our function. So inside that function we have detected label, which we return here. Here it is. We are returning detected label. So if we call the function in our main file, so we have now detected label values. So here we call our detected label value. If it is red is equal to red, then we are going to put the ID on the rectangle top left corner, detected vehicle, and then we are going to make the detected vehicle rectangle color red. Why red? Because my vehicle is, or we can say any other vehicle is basically violating my red color signal. That's why I have mentioned the red color. And if we detected if we match this condition, so we want to save the car, or simply we can say we want to save the scenario. So for that, simply I have created the timestamp. So here I have import time. Here it is, as you can see, from date time, import date time. So we are going to create here a folder, and inside that we are going to create a current date folder, and inside that we are going to save our detected vehicle image. Simple. So timestamp datetime.now strf time, this is the method, hours, minutes and second, and image is equal to file name. So this is what my file name is basically current timestamp .jpg. So when we detect the car, if there is a red color, if there is a red signal, so we will save that particular car along with the signal inside the folder with the image name is basically timestamp, the current timestamp, and extension is JPG. And we are going to simply use here, basically we want to, as I mentioned, we want to when our car is basically inside our region of interest area, if we match our condition, so we are going to simply assigning here a tracking ID. For that we have our tracker. So inside our repository, here it is, as you can see, I have already mentioned tracker.py. So it's tracking each vehicle continuously. Here it is, as you can see, from tracker I have import the tracker. That's it. So here it is, I have called the tracker.update. So if you don't know how to use the tracker, I have already created several previous video. I have created the computer vision playlist. Watch the playlist, then you will get a detailed idea how to use the tracker. Simple. So here it is, as you can see, I have called the tracker, and then we will get again new value for rectangle x3, y3, x4 and y4 along with the unique ID for each vehicle. Simple. So when our object or when our vehicle inside our region of interest area, and if there is a red color, we want to save each car with the color, means with basically the signal current color. That's it. So then else we don't want to detect anything, means we don't want to detect anything, means we don't want to save the car. We only want to create a detection with green color rectangle on the vehicle. So here it is, as you can see, I have passed the ID. We are going to track. If the color signal color is basically red, we are going to track the car. If the signal color is green, also we are going to track the car, but we are not saving the detected car if the signal color is green. Simple. So here only I have created cvzone.putText rect method. We are going to put ID on the rectangle top left corner, and the rectangle color, as you can see, I have mentioned 255 because we are detecting this as a green color, so we don't want to create a red color for a detected object rectangle. That's it. It is really easy. It is really easy. So now I will start the code. So this is now the practical, as you can see. So this is what my region of interest area. Now there is a green color signal, so green label. So when the vehicle pass, if the green color, as you can see, we are, as I mentioned, if there is a green color, also we are tracking the vehicle. So there is a tracker ID, as you can see, for this car we have 10 color, 10 is the ID, and but right now the color is green, so the detected object rectangle is green. Simple. And it will not save this car because we mentioned if only there is a red color, then only we want to save the car. I'm skipping frame manually. So now watch for this car. As you can see, it's already crossed our region of interest area. It will not save because right now the color is green. And as you can see, now there is a red color, the red color rectangle on our signal, and red means we have now red signal. And watch this vehicle, it's already crossed our stop line and it's now inside our area. As you can see now, because there is a red signal and the car is cross our area, so that's why there is a red color rectangle. If there is a red color signal and if car inside this stop line, it means the car is not inside our area. It is basically the condition for traffic rules. You don't want to cross the stop line if there is a red color signal. This is the condition, simple. So right now this car, there is a red color signal, but the car is not stop at the stop line, but it's go inside our area. So this is what our restricted area. So if it is inside our area, the rectangle is red and it will capture and it will save this car image along with the full frame. Simple. So now we have done. Now if you open the repository, inside that, as you can see, it's created the save images folder. Inside that today's date folder, and inside that we have current time with .jpg image file. And if you open the file, as you can see, the red color, the tracking ID, and the car. As I mentioned, the condition, the traffic rule condition is what? When there is a red color signal, you don't want to cross the stop line. If, of course, the car crossing the stop line, if, of course, means if it is inside our area. So then there is a red color rectangle and the image will save inside our folder, as you can see, with current date, and current date is basically our folder and current time is basically image file name. That's it. So this is how, friends, with the help of tracking method, the color tracking method, opencv color tracking method, you can detect the color from traffic signal, and simply with the help of yolov10 you can detect the vehicle as an object, and then with the help of polyline you need to select your area, region of interest area, and match the condition. If the condition is matched, simply create the rectangle, the red color rectangle for basically violating the rules or violating the traffic rules, and just save the detected vehicle inside your folder with current date as a folder name and current type as a file name. I hope you all clear. I have mentioned the full code inside repository. So we will meet our next video. Till then, thank you, take care, and bye bye.